Hello everyone, this is Stella. For this Mechatronics Midterm project, I teamed up with Real, and we want to make our electric car. Real did a good job putting the car together, and my job is to do the coding. We want the car to do obstacle avoidance and remote control. To achieve that, I learned a lot from the tutorial on the Alego website. This is the code for our obstacle avoidance. The code has 5 main parts, the define code, and the subprograms for the motors, and the subprogram for distance testing, subprogram for servo, and the main body, the logic code. So in the define codes, you can see, besides those basic code to determine which pin is connected to which electric part and the setup for car speed, we also have a library file installed. It's for the servo. And for the motor part, since in our car there are four motors, each controlled a different wheel, so it requires like 6 lines of code to do one motion. For example, to do the forward, you need to write all this, and to do the backward, you need to write all this. If we just put those codes directly into the logic code, it would be too complicated and too long to debug. So I put them into those subprograms. So here you only need to write forward, and it represents all this. And we need to do 5 motions. Of course, it's the forward, backward, left, and right, and stop. Followed up is the distance testing subcode and the setup for the servo. It's a little bit complicated to explain those codes because like some library thing is involved, but in order to make the servo and distance testing to work, the code is just like this. So I basically just copy and paste them in here, and it works just fine. Remain here is the main body of my code, which is the logic. Let me briefly introduce, explain the logic inside it. It's a loop, which means it will continuous to repeat itself until you turn the car off. So the distance sensor will face forward at the very beginning to test the distance in the middle. So if the middle distance is smaller than 40, the car will stop. And it will stop for a half second, and the servo will turn to the right, and it will stay in right direction for a second to test the distance on the right, and then the servo will turn left, and it will turn left. It will stay left for a second to test the distance in the left direction. And after that, the servo return to the middle directions, and it will compare the right direction with the left direction. No, it's not direction. Sorry, it's the right distance with the left distance. If the right distance is smaller, the car will turn left. And yeah, if the right distance is bigger than left, you will turn right. But If both the right direction and the left direction is relatively small, the cars will turn back. And after they did all these things, the car will keep moving forward. My code for remote control. It also have 4 parts. The first part is the define code, and the second part, similar to the obstacle avoidance, is the motor part, and then it comes with a setup code for the remote control, and here it comes the logic code. The principle of remote control is that each button on the controller have 2 sets of value. So we need to build connection between those values with different car motions. As we can see here, we have 5 motions for the car. So we only need to use 5 keys on the controller. So those key 1 to key 0 and start and hash doesn't do anything. In this case, we only need to use those 5 keys. And here is the first set of values, and this is the second set of values. So an external library file is also required for this whole function to work. You can find it is an external library, unlike the first one for the servo. You just add it in Arduino. This one you need to download a zip file and then put the library file into the library folder. You can find the file in Sketch, include library, and add zip library. The coding scheme matched this IR remote controlling is called NEC protocol. It just describes how the remote controller, how to say that, the remote controller interact with the IR receiver. Is kind of complicated, but it doesn't do anything with the code. I think it just describes why we need 2 set of values. For the setup here to be from here, this is the logic, sorry. For the setup of the things, to be honest, I don't quite understand. I just copy and paste from the tutorial and from here. So this is also something to do with how this IR receiver control the motors. Again, I don't quite understand how this part works. So what's the logic behind this part of function? I just copy and paste, but it works just fine. But the logic here is just when it detects the first set value from F and the second value from F, so it do forward. And similar to that, when it set both the first value of backward, and so both of the value has to be tested, it do the back motion, and for left and right and stop is just the same, and it's in a loop function. So